Good day everyone! Welcome back to our next part of General Mathematics, and before we begin, let me introduce myself. I am Engineer Adrian Miguel S. Omengan, and I am the third placer in the recently concluded Electronics Engineer and Electronics Technician Licensure Examination. I also graduated as magna cum laude from Polytechnic University of the Philippines, Manila. By now, we are done with the introduction to functions, rational functions, and inverse functions. Now, let's go to the exponential functions. Welcome to exponential function LBV gmath 1-4.1. In this topic, our most essential learning competency represents real-life situations using exponential function. The topics covered in this video are definition of exponential function and real-life applications of exponential function. For our learning objectives, by the end of this video, we want to know what is an exponential function and to know the real-life applications of exponential function. Let us now discuss what is an exponential function. Exponential function is a function whose value is a constant raised to the power of the argument, especially the function where the constant is e. It is usually expressed in this form: f of x equals a raised to x, where a is any constant number greater than 0 and not equal to 1. And x is the argument. However, there is another type of exponential function where its base is a constant called Euler's number, represented by small letter e. And this is what we called natural exponential function. The natural exponential function is a function defined by f of x equals e raised to x, where e is accurate to 8 decimal places 2.71828183 and called Euler number in honor of the mathematician Leonhard Euler. Let's provide some real-life examples. One major example of exponential function is the carbon dating, or more specifically, carbon-14 dating. Carbon-14 dating is a method of determining the age of an archaeological artifacts of a biological origin such as bone, cloth, wood, and plant fibers. While a person or any organism is alive, the amount of carbon-14 and carbon-12 in its body is always proportional. Let's say m over k, where m is the amount of carbon-14 and k is the amount of carbon-12. The amount of carbon-14 decays and regenerates while a person is living. However, when a person dies, the amount of carbon-12 remains while the amount of carbon-14 decays. Let's say, for example, after a certain amount of time, the amount of carbon-14, originally m, decays to half of its original amount, becoming m over 2. The amount of time for the carbon-14 to reduce to half of its original amount, thus the term half-life, is 5,700 years. Therefore, if the amount of carbon-14 reduces to half its original value, this means that 5,700 years has passed. So the date from the time that the organism is alive to the time of testing is determined by the ratio of the amount of carbon-14 and carbon-12. Therefore, when the remaining amount, again, reduced to half its value, this means that another 5,700 years has passed, meaning 10,400 years. Another example of exponential function is bacterial growth. In this example, let's take the E. coli. This type of bacteria doubles every 20 minutes. For example, in a container, there is initially one bacterium. After 20 minutes, it will double and becomes 2 bacteria. After another 20 minutes, it becomes 4. After another 20 minutes, it becomes 8 bacteria. Another 20 minutes, 16 bacteria, and so on and so forth. Let's try to answer some problems. Problem number 1. Determine which of the following is an exponential function. A. F of x equals cosine 2x. B. F of x equals 2x over quantity x plus 2. C. F of x equals 10 raised to x plus 1. D. Y equals 3x minus cosine xy. Letter A is a trigonometric function because of the cosine here. Letter B is a rational function because it has the division sign. It is the ratio of two expression. Letter D, we can say that it is a trigonometric function because of the cosine here. And since we have no other choice, C is the exponential function because of the variable or the argument in the exponent. For problem number 2, determine which of the following is an exponential function. A. F of x equals ln of 2x. B. F of x equals log of 10x to the base 2. C. F of x equals 10x plus 2. And D. F of x equals e raised to 10x. A is a logarithmic function, or more specifically, a natural logarithm. B is also a logarithmic function. C is a linear function. And D is the exponential function. More specifically, the natural exponential function because of the variable or the argument in the exponent. Let's go to problem number 3. Which of the following is an exponential function? A. F of x equals ln of 2x minus 1. B. Y equals cosine 2xy. C. F of y equals sin y. D. F of x equals 10 raised to 2x plus 1. Obviously, A is a logarithmic function. B is a trigonometric function. C is also a trigonometric function. And D is the exponential function because of the variable in the exponent. This symbol is called the caret, and this indicates an exponent. For problem number 4, determine which of the following is an exponential function. A. F of x equals x cubed plus 3x squared minus 5x minus 1. B. F of x equals 2 cosine y over sine 2x. C. F of x equals 10 raised to 3x plus 25. And D. F of x equals log of 10x to the base 2. A is not an exponential function but instead it is a polynomial function. B is a trigonometric function, or we can also say it is a rational function. Letter D is a logarithmic function, and obviously letter C is the exponential function because it contains the variable in the exponent. In letter A, let us not be confused because the argument or the variable is in the base and the exponent is constant. However, in exponential function, the base is constant and the variable is in the exponent. Problem number 5. Determine which of the following is an exponential function. A. Y equals e raised to sin y plus cosine x. B. Y equals ln of 3x. C. Y equals 2x minus 4. And D. Y equals 0. Letter B is a logarithmic function because of the ln. Letter C is a linear function. Letter D is obviously a constant. And letter A is the exponential function because of the variable in the exponent. And that's the end of our lecture. What we learned, what is an exponential function, and real-life applications of exponential function. In our next video, we will learn exponential functions, equations, and inequalities, and solve problems involving them. For supplementary problems, you may refer to Queck's book General Mathematics, Chapter 3.